This is Corey Willis with PPI, and you're listening to the Diesel Podcast.
I'm Adam Blattenberg from Diesel World.
Hi, this is Dan, owner of Dan's Diesel Performance.
I'm Christian Roth of BD Diesel.
I'm Braden Fleece, and you're listening to the Diesel Podcast.
What is going on, Diesel Nation? We're excited to have you guys with us today on the Diesel Podcast. Today's episode we actually got from Instagram. We had been getting a steady stream of engine-related questions, so we did a story on there, and there were a lot of great questions that you guys asked, and we picked a handful of them that touch on a number of different engines, and we're going to ask Cass from Choate Engineering for some answers. So we're going to talk about 6-liter, 7.3, oil leaks, if an emissions-equipped diesel is still reliable, does it still last as long as the older ones, and a bunch of other things in between. So we're excited to be able to chat with him and get your questions answered. Before we get to it, though, we want to give a shout-out to a couple of our sponsors. First is Mishimoto, and with 2020 wrapping up, heading into 2021, and there's going to be racing and vacations and things that are taking place in the spring and summer, and cooling, especially with transmission or engine coolant temperatures, is always important. And they're a leader in cooling technologies. We've chatted with them before about some of the things they're working on, ways that they test these products to be able to make sure that they work on your Powerstroke, Cummins, or Duramax, or if you have a custom application, they have universal products as well. Make sure you go to Mishimoto.com, check out what they have, and get your truck set up for racing, towing, daily driving, just being more efficient. If you're a shop owner looking for a place to buy Mishimoto products, make sure and look up Turn 14 Distribution. They've got warehouses all over the country to make sure you can get products as quickly as possible and keep your customers on the road. All right, let's get to the podcast with Cass and answering some of the questions we got from Instagram. Cass, welcome back to the Diesel Podcast on a different kind of episode we're going to do today with some questions from our audience that we posted up on Instagram asking people what kind of engine questions would you like to have answered, and went through and picked a handful of them. I think it's going to be a really, really interesting podcast. I don't know the answers to most of these, so I'm going to be learning along with everyone else, but we're glad to have you on.
Oh, glad to be on. As always, always fun talking about diesel trucks. Now that we have an open-ended questionnaire or whatever, I kind of feel like I'm in the dunk tank, but we're going to go ahead and try. I'll do my best.
The first one that we had is really interesting, and it opens up the topic a lot, is someone had asked about 6.7 reliability and longevity with emissions intact. And he didn't specify if it was a Powerstroke or Cummins, but I imagine it's going to be the same regardless of what engine. So with guys who bring in their trucks or cores that you get, or just questions that you get from your customers and dealer network, what do you see for reliability when the trucks are 100% stock?
Well, that's, again, like you said, that's a question that doesn't really matter. It transcends, year, make, model, or whatever. We got to understand what's going on with the engine, what the engine's actually seeing with emissions. And so the problem with it is the engine's getting it both directions. It's seeing it on the exhaust side, it's seeing it on the intake side. And anybody that's ever pulled an intake off of a 40,000 or 50,000 mile truck, they're just absolutely shocked to hear, or see, I should say, the amount of carbon buildup that's in the intake. The biggest enemy to any type of component, especially in material, is what we were working with, steel, cast iron, whatever it may be. But the biggest enemy of it is always going to be heat and pressure. And that can be, synonymous in some cases when we start thinking about certain aspects of heat and pressure. They're kind of, like I said before, they're wheels on the same axle. But so thinking in terms of what's actually going on with emissions. I mean, when your truck goes into regen, what's actually happening there? When the EGR valve's opening up, what kind of what exactly is the engine seeing? And what effect, I guess, what effect is it having on that engine? And most people think, the bad thing about the emission side of things, the real struggle for the emissions are what's happening at the diesel particulate filter and the excessive heat that's building up there. Well, that's all true. One of the things that is really is detrimental to the health and the longevity of the engine we see is these engines that come in and have they've been running the emission systems on them for 100,000 miles or 150,000 miles or whatever it might be. Every time the EGR valve opens up, it's redirecting exhaust gas recirculation, right? So it's got a pressure drop through generally a butterfly of some sort in the intake that will reduce the amount of pressure in one area to be able to basically try to reroute the intake and decrease the pressure across the intake so that it can pull from the exhaust side back into the intake. But what you're seeing when that happens is every time the exhaust valve, every time the intake valve opens up, this soot and contamination that's coming from the exhaust pipe is going right back into the intake. So what happens is it latches on to the valve stem. As the valve is being opened, it latches on. You're blowing this soot and this hot air, and it sticks to the intake valve. So when it sticks to the backside of the intake valve, you would see, and you still do, Exxon, they had a big campaign for trying to get people to use 93 octane gas and try to sell them a higher octane by showing the effects of the carbon and soot that was being deposited on the back of the valve itself. And it disrupts airflow, and that's true enough, and it can affect fuel mileage. But what does it really mean for the longevity of the engine, and what's the damage that would actually occur? Well, when these particles get onto the intake valve itself, what we start seeing is the guide from the clearances between the guide and the valve stem are typically around 1.5 thou to 2 thou roughly, and that's going to be relative to the engine type, valve diameter, and those things like that. But 1.5 thou to 2 thou, 2.5 thou, that's going to be in that kind of that clearance right in there. To give you a perspective of what I'm saying when I say for 1.5 thou for guys that aren't machinists or any such like, keep in mind that the human hair is about 3 thousandths. Okay, and that's 0.003. What happens is the contamination that gets on the backside of the valve, as it closes, it acts like sandpaper now. And it's tiny particles that don't seem like they would be really that effective, but the truth is it tends to wear the guides out really quickly. And what happens is when you have guides that are wearing out, when the valve goes to close, it's such a precise piece of equipment and designed such so that the valve guide needs to be concentric to the valve seat itself. If it's not, what happens is in very severe cases, the valve can fail itself, and the head of the valve can actually crack or break. Generally, that's due directly with heat, but it'll cause poor seating, and the valve face and the valve seat no longer are going to be meeting at the same point, so that you have poor if you have poor contact surface area there, then you're going to wind up losing compression. And if you lose compression, compression is life. I mean, if you don't have proper compression in the cylinder, it's not going to completely burn. It's imperative that you have it to be able to generate enough heat to burn the fuel that's in that cylinder. So the EGR system can definitely affect the long-term life expectancy of the engine through the contamination. And I'll tell you, on top of that, so you've got guys out there that are putting crankcase ventilation to leak kits on, and because they don't want that stuff being routed back to your engine. Basically, they'll take from the intake, the way that it's designed from the factory. The L5P uses a centrifuge, and there are some other manufacturers that do as well. It's pretty neat to see the one that the L5P actually came out with. But what it does is it reroutes the vapors from the crankcase. I'm trying not to chase. I swear, I'm trying not to chase the rabbit. It's such a big topic. But anyways, it is imperative that you have a negative crankcase pressure, or as close to it as you can, minimal crankcase pressure, because in order to have proper ring sealing, you need to have low crankcase pressures. You're having a positive pressure, then it's acting against the ring on the opposite side, and it's actually trying to push the ring back towards the piston itself instead of flaring out to meet the cylinder or the hydrodynamic wedge, which is the oil itself. But anyways, so they take these CCV deletes, and what I learned a long time ago in this industry is you can't do one thing and expect it not to affect a lot of other things. People don't realize that the very minute changes that they make to an engine, it doesn't just change what they think it's changing. It's actually having a tremendous amount of effect on things that they never even thought about. And we see this in terms of machining, where you change a dimension or you change the geometry of something, and you have to see how that relationship, for instance, if you were to line bore an engine, you go, okay, well, I've line bored the engine, and I've got it running concentric now. Anyways, got it running concentric, the crankshaft and the main bearing and everything. But if they didn't make sure that they went right back in the same position, now we're having gear train issues where the valve, or where the camshaft and the crankshaft are, all your gear lash is being taken up, and it can create problems there. Well, you weren't necessarily thinking about that in terms of the line boring. But to go back to what we're saying, the crankcase ventilation is extremely important because of the way that it's routed. It's routed back into the turbocharger. It's pulling the vacuum, right? And from there, it's going through the intercooler, and from the intercooler, it's going back into the intake. The problem is the people don't like the idea of that going through their turbocharger because, and also, you keep in mind, these are the same guys that have tremendous amounts of blow-by, and because they have that, they're seeing a lot of oil that's accumulating in the intercooler. It's leaking sometimes around the boot, and instead of fixing and addressing the problem, they'll run some type of device. I say device, it's just a hose or something from the valve cover. They'll disable the hose going back into the intake, and they'll just run it to the exhaust, and they'll burn it out of the exhaust. But the thing is it's a Band-Aid. It's not even a Band-Aid. There is no fix. That's not fixing anything. Now you're seeing it burn out the tailpipe, but it didn't matter. What you've done is you're no longer creating this vacuum in the crankcase itself. You had crankcase pressure to begin with. That was your problem. But what that does by rerouting that back or leaving the crankcase vent where the factory had designed it, is it allows oil to be deposited on the back side of the intake valve. And because that oil is deposited on the back of the intake valve in a vapor form, it helps to lubricate the valve guide. Now that's one thing that it does. So by using a crankcase vent, and there's people that I'm sure are listening, and they're going to be, this guy's crazy. No, it's really, if you think about it, it makes perfect sense. And generally when I try to explain something, I want to do it in a full gamut so that we can understand. It should make sense when it's all said and done. This isn't smoke and mirrors. But because of that oil that's being deposited on the valve stem, and it helps to lubricate that, the relationship between the guide and the stem will be a lot happier. Now, there's also another thing that occurs, and it's called a tribofilm. And a tribofilm is what is deposited actually on the back side of the valve face itself. Once that's deposited, it actually will decrease the wear of the valve itself, and or the valve face and the valve seat, and it helps to seal. So you can't just do one thing without it making a big change overall. The other part of the scenario with emissions are obviously in certain trucks. You've got selective catalyst reduction systems, diesel particulate filters, diesel oxidation catalysts. You've got diesel exhaust fluid that we use now as a catalyst. There's a lot of things that are different when somebody says emissions. The effects of emissions are different because the approach to emissions is different. The approach to maybe the Duramax emissions versus a 6.4 liter is quite a bit different. The LML versus the 6.4. The 6.4, and we've, not to beat a dead horse because we've discussed this before, but those that haven't heard the other podcast, I'll run through that really quick. One of the main detrimental things about that design was, in theory, on paper, it sounded really good. What they were going to use is the diesel for the catalyst, and to be able to ignite 1800 degrees into the diesel particulate filter to help burn off hydrocarbons and soot. Well, that's fantastic. How are we going to get that primer, that charge into that diesel particulate filter? So what they decided to do was come up with an idea and use a number 7, number 8 cylinder on the exhaust stroke. The problem with that leads to a whole nother episode that we could talk about, and that's surface finish on the cylinder walls and how a hydrodynamic wedge on the cylinder wall is the oil is actually the gasket between the ring and the cylinder wall. If you don't have that gasket, you don't have that sealing. The problem with it is diesel fuel is an excellent cleaner. It does a great job at removing oil. But it's a terrible lubricant for things that have extremely high 10,000 psi pressure, 15,000 psi pressure, even more than that. It's depending on the boost application, the ring application, and other things that go into that. But what happens is it winds up washing the cylinder wall. When it washes the cylinder wall, then now you no longer have that film. You start wearing your cylinder walls out in the number 7, 8, and number 8 cylinder really, really quickly. Then what happens is the fuel gets into the crankcase. As it sprays now with the piston cooling jets and the oil, the splash oiling, it's washing down the cylinder walls. And the rest of the cylinders, they wear out a lot faster. So everything's bad. There's nothing good that comes from it. Okay, it's just then that's the ugly truth of it. There's nothing good that comes from that. But whereas in complete reverse, you have an LML or something like that has a 9th injector that actually sprays the diesel fuel into the up pipe, or excuse me, it sprays into the up pipe on the 11 to 16 year model, where that actually is further downstream, and instead it was an exclusive because it kept this catalyst away from the engine itself. It had a lot of fringe benefits with it. You didn't have the same amount of wear on the cylinder walls. However, what it would wind up doing is eventually through the heat, it could cause turbocharger failures, turbo seals to fail. It can cause, and we see this a lot in the 6.7 Powerstrokes, where especially the earlier year models, where the 11s and 12s and so on, they had the exhaust was failing on the cylinder heads, and it would break off. Originally, it was thought that the glow plugs were causing this. Well, they're a little bit later on, they figured out it's not. It was kind of like the chicken or the egg, which came first, right? They didn't really know, and they were finding that they would have glow plugs that were damaged, that were broken. They would have exhausts that were damaged, and they found out real fast that it was actually the exhaust valve that was causing the failure, and it would knock the glow plug, the tip of the glow plug, and knock it out. And it got so bad that if they were having certain fault codes that were in the engine, they would tell the tech, don't try to diagnose it, just replace the engine. And you just feel like you went from 0 to 60 in like a split second. You're here to diagnose a glow plug, And the guy goes, yeah, replace your whole engine. But, obviously it was low compression that was going to be attributed to the same, or it would be accompanying the same problem as well, I should say. So emissions has a lot to do with longevity. There's another thing that can go on, and I know I want to get to other questions, but I mean, it's just such a huge, I was saying, like I first said, you can't do one thing and it not affect a ton of different things. Well, here's another thing people don't figure on. The coagulation that develops for the oil, because of the soot load, you don't get near the life out of your oil changes that you would pre-emission days. The issue with that is that now all this soot that's getting on the side of the cylinder wall is getting washed back into the crankcase. So as it's washing around in the crankcase, that's the reason why people ask me, what kind of oil should I run? And I always ask them, is it a truck that is one that was built with emissions, or is it being ran, it doesn't have emissions on it, whatever. Because even good oils become bad oils with high zinc dichlorodithiophosphate in them, because you can start, if you think you're running a really good oil, you go, well, I can run this thing for 10,000 miles, but then you've got this huge amount of soot load. What that does is it actually has a charge in it, that it's a positive charge, that it'll allow all that soot to coagulate and develop and maintain a position in the engine where it will cause wear. Whereas it's fantastic, and that's great, but with that contamination in there with it, it actually is counterproductive, because what you want is an engine that 75% of, they tell you, will be developed on startup, and that's because that film of oil is now, it's not present. And when you crank the engine over, it takes it just a few seconds, or less than a few seconds, but it takes just a short time for the crankshaft to get up like a skier would be on the water. If the boat's not moving, the skier's in the water. So that's kind of the same scenario. As soon as the oil pressure comes up, that crankshaft is like the skier, and he gets up on top of the water. But there's a certain time frame that it takes for that to happen, and that's where your wear occurs. Where the zinc is great is because it remains in a position that it can do the most good. But the bad thing about it is it remains in position where it can do the most good. It also is taking something with it. And if there's a lot of soot load in that oil, then it tends to stay in that same area. And that's a big issue there. So, that's, I don't know how long I probably spent on that question, but that just that's a 30,000, elevation panoramic view of what actually is going on, just with the engine components, not to mention the other components, like we say, of turbochargers or such like.
It's a common question we get a few different ways throughout the year, is from guys who are either we had an email from a guy who had an LML and he had some issues with it, and he was looking into a different truck, and he had come across some of our episodes about 6.4s that you mentioned earlier. And because there's been so many changes, like from a 2008, say 6.7 Cummins to a 2020, it's not really a direct answer as to what's the reliability, what's going to fail, and then you get into which brand and how was it treated. Was there a lot of idle time on it? There's so many different components to it, but I think people are looking for. I think the main thing, one of the main things that draws people to diesel is the longevity, and we think back to a 97 Powerstroke or a 12 valve or something like that, and some of the high mileage trucks that are out there, and we think, well, I want to have this truck for 300,000 miles, 400,000 miles, even more. And they try to apply that same want or need to, a brand new truck that has these systems on it. And so I think that's where people are looking for, direction. Am I going to get 100,000 miles out of this truck? Is it going to be 200? I remember a long time ago reading on Cummins Forum, this hot shotter, they got 225,000 miles. I think it was on a 2008 truck, and it was all stock, and everyone was just amazed. And some people didn't even make it that long; they had other issues, and so it's just it is a really tough question to answer because there's so much involved with it.
Yeah, to reiterate, what's the best truck? If I was going to buy a truck, what kind would I get? I think that's the question. Am I reading that right?
Yeah, there was one that came in. If you're going to buy a truck, what would be the one to look for, the one to get, regardless, say brand loyalty aside, is if you're just focused on reliability, longevity, which one would you
the one with the best radio? Well, yeah, that is a huge. Okay, all right, let's break this thing down, because I get that question a whole lot, honestly, and all joking aside. The truth of the matter is this. Okay, you're asking me what is as far as a truck. If I was going to go buy a truck today, what kind of truck would I buy? The issue with it is a truck is more than just just four wheels, a bed, and a cab. There's an engine, there's transmissions, there's electrical components, there's the suspension on the truck. There's a lot more to it than just as far as reliability goes. Okay, which one would I put my money on that would last the longest as far as the engine goes? That's a more specific question. Which one do I prefer? Brand loyalty aside, that I think has the best package. And like you're saying, you have to really think about the question, because man, I don't know of another industry that's changed quite like this one. I mean, you think, how long has a 5.3 liter gas burner from GM's been out? I mean, I don't know how long it's been running, but it's the 6.2 liters. These things have been going for a long, long time. As far as the technology behind the engine, it's not had any when I say major changes, I'm talking something comparable to, we were on the 7.3. Now we're at the 6.7 running steel pistons, and we were running a hydraulically actuated, electronically controlled unit injection system where it was making 20,000, 21,000 pounds of rail pressure, or I shouldn't say rail pressure, but injection pressure, and now we're making 36,000 psi pressure. I mean, that's totally, you're talking 10-speed transmissions versus a 401, or no, a E40D. That's huge. I mean, that you're talking complete advances that aren't really fair to compare. It would be like trying to say, the difference between a 5.3 and a Tesla. I mean, that as far as technology is concerned, that's how much the diesel world is actually advanced. So with that said, I'll try to lay aside some of my preferences and my biasness, I guess, towards certain brands. I don't know that there's really a bad. Let's talk about just long blocks first, okay? Where I feel like the best long block out there. If somebody came to me and said, okay, you have to build the best long block, you can choose your components and pick out of everything, I can tell you what I'd have, and people are going to disagree with me, but I'll tell you. As a machinist standpoint, this is completely unbiased. This is the truth, okay? If I wanted the best engine out there, and I would want this. I would want the bottom end of the 6.0 or the 6.4 with the bed plate, okay? I want a bed plate. I want the connecting rods out of the Cummins and the robustness of the internal components, and I want the block out of the Duramax. People go, what are you talking about? Well, the truth of the matter is the best block out there, people are going to disagree, and they're going to say, oh, man, Cummins is it. They're great. There's no doubt about it. But the truth, the very best block out of all of them, if we're talking about cylinder wear, you won't wear a Duramax block out. I mean, it's just the truth. You don't wear cylinder. And I'm a Ford guy. I mean, I prefer, I own a Ford. But the truth of the matter is when you have an induction hardened cylinder wall like they do, until you have machined one of those blocks, you really don't have a say in it. Because I can tell you this, if you go and listen, and I think we put a video of this on either Chode Engineering or Diesel Doctor page, I don't remember. But you can hear the hardness of the induction hardened layers. There's 5 of them, and you can count them. And every time it goes through and it passes through, and that carbide cutter goes through that, you can hear that the rock wall hardness of that cylinder wall is a tremendous amount more than what a Cummins or a Powerstroke would be. So that's the best. As far as the cylinder wall is concerned, that's the best block. The best bottom end really is going to be a bed plate design. It always has been. Cummins tried to do a lot more for the bottom end of their engines back in '03 when they came out with the girdle, but that's still that's a very big shortcoming from a main cap with a girdle versus a bed plate. Bed plates have their issues, but for the most part, there's a lot more rigidity to that. And if you see these guys, I mean, that are making big power and they're using this engine for performance, and they're making a billet block. A lot of the guys out there that are making billet blocks, they're making a whole bed plate design. It's just a lot more rigid. So as far as a long block is concerned, no. As far as a short block is concerned, because, I mean, we can break this thing down and I can tell you, the pros and cons to the point where you're like, okay, enough's enough. But as far as the short block is concerned, those are the best of all. That's the certain engines are better endowed for certain things. Used to, I would have told you the Cummins fuel system, even until the CP4, why they went to that, I know why they went to that, because of emissions and because of greater atomization, because of lower hydrocarbons. I get all that. It stinks. It's a terrible design. Everybody knows it, and Chevy's had problems with it, and Ford's had problems with it, and I guess Ram just wanted to get in on the party and had problems with it too, because that's another thing they got going on. But as far as that goes, that's my, and I know somebody's going to say, well, you just didn't answer anything. You just told us the greatest of all of them, when that can't be. That's just, you got to pick vanilla or you got to pick chocolate. You can't mix it. But so the 6.7s, I'll just kind of break it down real quick. And I'll back up. I'm not going to go to brand new trucks like, something you buy off the lot right now, because I think most of your listeners are probably guys that are looking at trucks that are 5 and 6 years old. So we're going to kind of stay in that range right there. As far as that's going to put you in the 6-7 range for the Ford, right? So we're going to say 2015-ish, somewhere in there. That's going to put you in the LML range for the Duramax, and that's going to put you obviously in the 6-7 Cummins range. The issues that we see out of the LML are typically, and people are going to stone me over this one, but guys that are running, I'm not going to name the names of the tuner, but they're can tunes, a lot of them are. They're cracking pistons on the LMLs. There's two major things that we see fail. Typically, our LML will crack a piston, or number two, you'll wind up taking the crank pin and stripping the crank pin, and you would be surprised at how many guys misdiagnose that. The truck's shaking all to pieces, and the harmonic balancer stripped that pin. That's generally the failure that you're going to see of that. The 2015 6.7, as far as the failure goes of what I might see on the engines, it can be bottom end failure. Very seldom do you ever find the piston cracked in a 6.7, and that's mainly to do with the combustion bowl design, like the 6.7 Cummins. Cracking, yeah, does it happen? Yes, in the Cummins, but it's not nearly as present as it is in like a 6.4 Powerstroke or an LML. Those are the ones, and the reason why is if you look at the LML, it's a re-entrance style bowl piston, which means that if you look at the bowl and you do a profile view and a cross-sectional view, you'll look and you'll see the lip as it rotates and comes back towards the center of the bowl. What happens is it creates a hot spot in the piston. They realize this. That's the reason why Cummins went to the design that they did, and Ford as well. There's a lot of similarities between the 6.7 Cummins and the 6.7 Powerstroke bowl design, but the 2015 Ford is a good truck. I like it's a good platform. The 2015 Ford I didn't like because of the rods that are in it. They're just a pathetic excuse. Why would you do that? You knew I was going to buy a diesel truck, and you took these rods out of a go-kart and you stuck them in my engine. Why would you do that to me? You just want to take those things and throw them at the engineer. But they decided that they were wrong, and they repented back in 2017, and they came out with a much beefier rod. There was a transition. They're goofy because they've got three different rods. They got the 34 millimeter version, then they got the 35 millimeter version, then they got the 2017 that's actually a 35 millimeter, but it also has a good, a decent rod that resembles a lot like a 6-liter. And then, the 2020s are steel pistons, and they're a whole nother ballgame. But that's the weak link. I have seen trucks hydrolock that a 6-liter would not have been a connecting rod, whereas a 6.7, when it hydrolocked, when it was a 2015 or 14 or 16, actually, the one that I'm thinking of most recently, and it just bent the connecting rod, and it took the bottom of the skirt of the piston, the cylinder wall, and it broke it out. So if I was going to choose a 6.7, somebody said, you have to get something within the last, 5 years, I would try to shoot for, my preference would probably be that one with a better connecting rod. It makes more power. It'll hold more power, not make more power, but it'll hold more power. You're still, unfortunately, you're stuck with a CP4. So that's, a mark against it. As far as the Cummins goes, the HE351V turbochargers were a big problem. We see a lot of that with contamination through the turbocharger from a lot of idling, coking, things of that nature. The engines, typically, I'll tell you, a 6.7 will blow a head gasket far faster than a 5.9 ever would. The reason why is a couple of reasons. Drive pressure is it. That's the main reason, but there's a lot less gasket material between the cylinders themselves, but it's not the amount of gasket material that determines whether it blows or not. It's a Siamese cylinder long block, or short block. But what happens is because you're running a variable vane turbo or a variable geometry turbo, whatever you want to call it, you have a lot higher cylinder pressure, and because that piston's trying to compress the drive pressure coming up, the exhaust pressure coming up, it increases the amount of cylinder pressure, which will in turn cause for failure of the head gasket. So 6.7 has always been more problems. The other big thing that I don't like, that I've seen a huge problem with on 6.7s, And I just realized by the time I get done, everybody's going to be like, I'm done. I'm walking everywhere I go. I'm not buying a diesel truck. So I probably killed my whole, my clientele. Thanks a lot. Again, you don't ask me questions. I'm the world's worst to ask this question to, because I will just beat a dead horse. But valve seat failure or dropping out, 6.7s from the factory, they don't really put much of a press fit on the exhaust seats themselves like they should. And if you get that thing hot, I'll tell you this much. You know how Jasper gets their seats out of a Cummins head?
How's that?
What they'll do is they'll take a jig and they'll bolt the head down, and it has holes where the cylinders would be. So they bolt it down, they stick it in an oven for 600, 625, 650 degrees, and then they wait. And guess what happens? All the seats fall out. That's terrifying. Scare the crap out of you. But that's how they get it done. That's how they get them out. But anyway, if you get a Cummins hot, a 6.7 Cummins hot, you are a lot more apt to drop a valve seat. And if you drop a valve seat, then you're going to take out the engine with it. So they've all got problems. There's not a single one of them, I can tell you. Chevrolets tend to have, if we're talking trucks, Chevrolets tend to have more issues with electrical. And the thing I hate about a Chevrolet, and I love Chevrolet, but the thing I hate about them, or General Motors, is it's like they would save 50 cents, and all they would have done was put 2 inches longer, or 1 inch longer wire instead of stretching it like the LLYs, right? Remember when the number 4, the number 7 and the number 2, they would take the injector harness and then do like a 180 with it and then plug it in, and they're pulling on this harness. The problem with it is that's okay, but the issue is the engine mounts would break. Not only would that be a problem, whether the engine mount didn't break or it did break. I had a customer that brought a truck to me one time, and it would only have this problem when he was taking off from a red light with a heavy trailer, and it would actually go into limp mode. But what it wound up being was the engine mount was broke, and you would have more torque with the engine with that trailer behind it taking off from a red light, and it would pull on the harness every time it would do that. And it's just goofy stuff. But Chevrolet they're just notorious for that. That's, as far as suspension, that's a whole other topic. As far as transmissions go, that's a whole other topic. But that's the cons, I guess, to all of them. I don't know if I really answered that question very well.
It's so hard to answer. And it's something we get a lot on social media. And I'm like, well, we talk to a lot of different kind of people, with whether they're into performance or maintenance or enthusiasts of all the brands. And I'm like, you just got to pick what you're going to spend the money on, when you have it. And do you like the styling? Do you like how it rides? Do you like the interior? And kind of go from there.
Well, and that's absolutely right. That's the best answer is they've all got problems. And, I don't know that I wouldn't, if it were me and I was going to go buy a truck, I'll tell you what I would have. If I was going to go buy a truck tomorrow and people are going to go, you're crazy, that's the worst truck ever. Well, yeah, you're probably right. From the factory it was terrible. But I like the look of the 6.4, and I like the way that it makes power. However, I would not want one from the factory because I know that thing's not going to last. But I know something else. I know that we can make them last, and we've done a lot of aftermarket upgrades for them. And that we can make it dependable through the machine parts that we're using, and that's kind of the goal that when I go into a platform, I'm looking for, as you can tell, if you don't take away anything else from everything I've said, you can, just from listening, I've seen all the problems with these engines, and I'm looking for the problems the entire time I'm working on this truck, whether it's wrenching on it or whether it's the machining on it, and I'm looking for that so that I can make it better. And that's one thing that we are 100% for, is making these things reliable, so that when you do get an engine from us, that we've addressed the problems and the shortcomings that are from the factory. So pick the truck, like you said, that you like the interior, that you like the package of the truck, right? And if it is a shortcoming in the engine or something like that, there's something we can do to make that reliable. So don't let that deter you. But the way that I generally would tell somebody is I'll look for an engine or a truck with a blown engine, or something that's a fixer-upper if I don't have to have it right now. And send it, you can send the truck to us, you can send the engine to us, you can do whatever you want to. We can install the engine, or we can and build it for you and do everything you need, or we can build you an engine custom and send it to you. But and then that way you can get a good deal on the truck. A new truck's going to cost you $70,000 if you get loaded out plus. I mean, golly, 70, 80. I mean, I've seen some of them that were $105,000. So it depends on where you want to spend your money on it. But it's definitely well worth doing that. Your money ahead to do it and get a really good deal, because one thing that's really the bad thing about diesels are everybody's petrified of a diesel truck when it goes down, because they know it's going to be expensive to fix. And so you can't, unless somebody knows something as a buyer, they're not going to bring much money broke. So that plays in your favor a little bit. It can also, if you're on the other side of the coin, that'll hurt your feelings too. But if you can find a good deal on a truck that you really like with a blown engine, that may be your best bet. So that's just something to keep in mind.
These last two questions we got, they're Powerstroke questions, and I know a lot of people with this next one are really going to be paying attention to the answer. And it says, how to completely leak-proof the high-pressure oil system. And when I think of that, I think of a 7.3, because I have some friends with 7.3s, and they're always chasing oil leaks and different things. But it's something, especially with the time, that these trucks have been on the road, that comes up a lot. So when somebody brings in their truck, or ships one to you and says, hey, I want the 7.3 gone over, what are some things that they can do to eliminate leaks or just track them down or kind of stay on top of that?
Okay, so when we say leaks, we're talking high-pressure oil leaks, or are we talking oil leaks in general?
He said high-pressure oil system.
Okay, the high-pressure oil system. Okay. All right, no smart aleck comments there. On a 7.3 or a 6-liter, we're going to specifically talk about the 7.3. 7.3, everything pretty much was external except for you're only dealing with, it's no different than the DT530, DT466, 3126 Caterpillar. These are all HEUI injection system engines. But the 7.3, you had a high-pressure oil pump externally, not like the 6-liter where you had it under, in the back of the engine. But it's right up front, and then you've got the two lines coming off to each one of your cylinder heads. So everything is pretty much external except for the injectors. So that's a really good question, because somebody might say, well, I mean, there's just injector O-rings really, to talk about there. For the most part, that's it. That's about it. One thing that I'll tell you that I learned a long time ago about that was be careful where you buy your fuel. I have seen guys that would use, we would put brand new Ford injector O-rings in their truck, and it was like clockwork. 2 years later, they'd come and they'd be completely eroded. And for a while, we were trying to figure out what in the world is causing this, and it was actually algae. It's very aggressive towards the rubber, the material, the vitral seals and stuff that the injectors have around them. That's a big problem. So be careful where you buy your fuel. As far as leak proofing or keeping that, the only thing you can do is to reseal your injectors and make sure that you're buying fuel that's not contaminated. And if you've got an external tank in the back of the truck, those things are really handy, but they are very problematic. I see more issues out of guys running external tanks than just about anything else. So I guess that's about all there is to that 7.3. That's the beautiful thing about the engine, is the simplicity in it. Whereas a 6-liter, how do you leak-proof it? I'll tell you, this is the other thing, flip side of the coin. 6-liters, I think about it more so than I do the 7.3. 7.3s don't have oil temperature problems. They don't, because they've got a bazooka for an oil cooler on the side of the engine. Whereas the 6-liter, obviously not so much. You've got 14 layers, 7 coolant, 7 oil, and that's how you leak-proof a 6-liter. If it's an 03, obviously it's running a different setup. An 04, 04.5, they changed to the wavy rails, and then you had the log rails on the early ones. They had a different high-pressure oil pump, STC fittings for the 04.5 to 07, or excuse me, 05 to 07, so that there's differences in standpipes and dummy plugs and things of that nature. How do you keep that? Let's say you just went through and replaced everything. The main thing to remember on the guys that are having all these injector seals that are leaking on the top of the injectors and that are having a lot of issues with oil leaks, The standpipes and W plugs, when they updated them with the Teflon backing ring, that fixed a lot of problems. That was really good. When the SGC fitting came out, obviously it had a 100% fail rate. That was a big one. That took care of that problem. The biggest things you see now that are leak problems, I guess, are the top seals and the injectors, or the pucks themselves that are on the rails. The main reason for that is because of oil temperatures. 99% of the problem of that could be due to because of oil cooler stopping up and causing too high oil temperatures, and it causes that O-ring to erode a lot faster. So that's the best thing to do. Keep an eye on your oil temperatures and use a coolant filtration system. Run some VC7. I always get that confused. It's either VC7, VC9. Somebody correct me on that. But anyways, the block cleaner, flush it really good. And I'm not saying use an external cooler by some of the other companies because it does not address the problem like a lot of people think it does. But keep your oil temperatures down, and you really won't have much trouble with that.
Sort of worked out where this leads into a 6-liter question. And I know you've touched on it a little bit before. But this one said, how to get a reliable 600 horsepower out of a 6.0. So I know that there's a lot we could go into with transmission, turbo, things like that. But just as far as the engine is concerned, how can you maintain a reliable setup at 600 horsepower on a 6.0?
Okay, so we're just going to talk about the long block. All right, so if we're just talking about a long block, reliability on a 6-liter, I would, okay. All right, the reason why I kind of hesitate to answer that is because you're right there at that edge. 600 horsepower, and there's going to be tons of guys on here that are going to tell you. 6-liter, 6.4, 7.3s, doesn't matter what it is. Cummins, Duramax, they're going to say, oh, man, I can get a lot more power out of the rods than that. I can get a lot more power. You know, my buddy, he's got 2,000 horsepower on a set of stock rods. Yeah, I understand. The deal is this. All things aren't the same, okay? Your buddy may be getting that. That's great. But your buddy is running a 475 Charger, okay? He doesn't really start making boost until he's already through the natural power band of the engine of what it would be from the factory. He's until 3,000 horsepower. That thing's not even spinning yet. I mean, it's a huge fan. The thing about it is this: connecting rods. And I'm going to make this as quick and short as I can. Sustained load versus a instantaneous load is completely different. If you take something and you put a lot of pressure on it and you hold it there, the stress and the fatigue of the material will show up a lot sooner than it will if it is an instantaneous load. It's on, off, on, off. If we increase the piston speed, it can become more of an instantaneous load where it's on, off. If we decrease the piston speed, like for instance at 6.4, where we're making a lot of boost at a low RPM, then now we've got a sustained load. And I used to use this analogy when I was flying airplanes and doing aerobatics. You know, we could pull 6Gs, 7Gs all day long and have no problem. Whereas the guy in the F-18 Hornet, if a Blue Angel's doing that and he's holding it for a long period of time while the blood goes out of his head and to his feet, he passes out and he crashes and bad things, obviously happen. But the difference is the connecting rod's no different. That quick G load, that we were feeling just for a short moment, it didn't have that much of an effect on our body as the guy that's over there doing a split F and holding it all the way across the bottom end. Well, that is extremely important as to the longevity of the bottom end. If you're not running a big single charger, or if you're making 600 horsepower, at that point I'd start thinking I might want to really think hard about putting some decent connecting rods in here, aftermarket connecting rods. That's kind of at the point where just kind of, you're teetering. It's 600 horsepower doesn't tell you squat, okay? Because it doesn't tell you how much cylinder pressure, it doesn't tell you how much cylinder heat that you're dealing with, how much heat transfer you're getting from the top of the piston into the bearing of the connecting rod. You don't really have anything. 600 horsepower is an ambiguous statement as far as what it actually tells you what's going on with the engine. Because there's a couple of different ways we can make that power. There's safe ways, and there's ways that are going to be detrimental to the longevity. Moving from the bottom end of the engine, 6-liter, the bottom end of the engine is very robust. Other than the connecting rod at that power level, might want to take into consideration, like I said, aftermarket connecting rods. Moving from there, O-ring cylinder heads are a must at that point. That is when we do we sell a lot of cylinder heads that are O-ringed. but the main reason for that is a lot of people think that it bites into the gasket and it helps seal. That's really not explaining it very well, but that's true, and it does do that. But what it is it's a heat sink, and what it does is it takes the heat away from the firing area and displaces it. Heat and pressure, again, as we said before, are synonymous. So if we can lower the heat around that combustion area, around the firing area, the gasket, we can lower the pressure that's actually acting on that gasket itself. It's a must. Firing or O-ringing, not firing, but O-ringing set of heads for sure. And good camshaft and ported heads really help a lot. And the reason why I say that for longevity is we can decrease the amount of drive pressure, which will make the cylinder a lot happier. It makes the head gasket live a lot longer. And the ported heads and a good camshaft with a decent amount of duration and lift. On top of that, the camshafts that we sell, that we developed with Billy Godbold for the longevity of lifters through crack and wax style cam with low shock technology and microsurface enhancement, where it spreads that bearing area curve across the roller of the lifter. It sustains that load a lot more with a lot more stability. All those things are necessary in having a good, long-living 600 horsepower daily driver. It definitely can be done, but those are the components that I would be looking at first.
What's so cool in chatting with you, about 6 liters is how much, because I used to think, I would never have a 6 liter, or they don't make power, they're not going to be reliable. But I've learned so much through the last couple of years of, really jumping into them and learning how much is out there for them and solutions that it's so cool to see that platform, take off the way that it has. And there's a lot of 6 liter fans out there. There's a lot of people who, get them and they want to do different things, whether it's towing a trailer or maybe they take it to the drag strip or something like that. But it's been really cool to see the evolution, of that platform. And then you also mentioned the 6.4, a little bit, which popped up. But these, it's always really cool getting questions from our audience, and they're so varied based on, the kind of truck they're looking at or have or what they want. And I know you're busy and got a lot of stuff going on, but before you go, I wanted to ask you a little bit about your YouTube channel. I learned recently that you guys have one, and so our audience knows, like, what kind of content and videos and things are you guys putting out there?
Yeah, so that kind of started, and I'm hoping that I know they're working on that right now, and they're trying to get a lot of the information transferred over, and I think that's what that they've been busy doing. But starting back in the day when I was just the diesel doctor side, which we still have the diesel doctor as a full-service drive-in facility, and we do the engine install on one side, and we have Chode Engineering, and that's that's the engine building and the machining side of things. And you didn't ask this question, but I'm going to kind of throw this in there. We're in the transition stage right now. We're fixing to move from a facility that's where we're at right now. It's the one we're moving to is 10 times the size of the current facility. And it's going to be close to 80,000 square feet and 15 acres. So it's going to be really, really, really big, and a lot of room to do some really cool stuff. What we're hoping to do when we get in there is I'm excited about a new guy we're bringing on to the company. Haven't announced anything yet, but he's going to be head of marketing as far as the social media platform goes, where we're trying to put a lot of YouTube content out there and videos about what we're doing, what makes us different, how we can fix these problems. So what you're seeing right now on the YouTube channel is they're transferring a lot of the older videos that I had made back in the day when it was just, basically just me doing this stuff. And some of it is diag on, that's kind of how I got my start, working on trucks and figuring out what's wrong with this truck when it comes in and doing this, that, and the other. And so they're loading that, as well as the newer stuff, which is the machining side of things and some of the parts that we're making that fix the problems. So that you'll see a lot of advancement. I think a lot of things are going to be coming from that in the next 6 months. With just now, we've got abilities that we just didn't have before because we just didn't have the space. And I'm hoping that once we get into the new facility, adding a studio there, that we can actually do some bring in some trucks and do some builds and make a channel out of it where guys would want to see us build a 1,200 horsepower pickup truck or whatever it might be, see it from start to finish. And it's funny because we were talking the other day. I was talking to a friend of mine about this. I said, you think that guys are we're just passionate about trucks, but I mean, it's funny how people are so brand loyal to certain things. I mean, I can just see guys arguing over shoelaces. This is the better. You haven't tried. I mean, look at the guys with Red Wing boots and Thorogood boots. I mean, we are very opinionated people, and we're very passionate about what works for us and what we use. And I really have had my eyes opened up to that through this industry. And because of that, I think that there's a lot of stuff that we can do to bring good content to our customers, to enthusiasts that they'll be able to see. So be sure to check us out. Go ahead and subscribe to our Choate Engineering page on YouTube. But in the next 6 months, I'm really hoping that to see that really blow up.
As always, Cass, it is fantastic to chat with you. And when we finish up, I always think of all the new stuff I learned. So it was great for us and our audience to be able to get some questions answered, learn some things about emissions and fixing, or I should say, preventing high-pressure oil system leaks and making a 6-liter hold 600 horsepower.
Well, it was my pleasure, and as always, I greatly appreciate it.
Don't forget, diesel fans, make sure and head on over to emission-equipped.com. Check out what they have for cooling your diesel truck down, making sure it's running as efficiently as possible. And if you're a shop owner, need to get some Emission-Equipped products into your shop, check out Turn 14 Distribution. Give them a call. If you're not set up with them, they'll make the process super easy and let you know how quickly you can get products to your shop and keep your customers on the road. Till next time, keep the shiny side up.